Hey there, guys. It's Shami, and today we're going to be learning how to solve some basic exponential and logarithmic functions. So, first of all, we're going to start off with this super duper complex looking problem, but I assure you it is not that complex. So, first, we should try to simplify this as much as possible. So, as you should already know, 8 is 2 to the power of 3. So you could just transfer that. So 2 to the x plus 3, 2 to the power of 2x plus 3, 2. So we're going to multiply the 3 times 3, 9x. 3 times 8, 24. So 2 to the power of 9x plus 20. So now, since we know that the bases are the same, so 2 and 2, it's okay for us to assume that the exponents should equal each other. So we're going to simplify it and bring it down. 2x plus 3 is equal to 9x plus 24. So now we're going to solve this. Negative 24 both sides, and then negative 2x, that's a 2, negative 2x on both sides. That should give us about negative 21 is equal to 7x. And we can simplify this to x is equal to negative 3. And that is in fact going to be our answer to solving this. So now we're going to do another problem that's a little bit more complex in standard, because 243 to the power of 6x plus 6. So now we're going to simplify this even more. So as some of you may already know, this is going to become 3 to the power of 3. This is going to become 3 to the power of 5. So we're going to simplify this as 3 to the power of 3, 3x plus 1. That is equal to 3 to the 5, 6x plus 6. Sorry guys, the numbers are kind of looking a little mushy here and there. And now we're going to combine these together. It's going to be 3 to the power of 9x plus 3. That is going to equal to 3 to the power of 30. 30 plus 30x plus 30. And now we can just assume that since the bases are the same, that we can directly simplify that our exponents are equivalent to each other. So we're gonna just simplify this even more, say 9x plus 3 equivalent to 30x plus 30. And now we're going to simplify this even further so that we can find what x truly is. So this is going to be, we're going to subtract 9x from both sides and subtract 30 from both sides. 9x 30, and that should come to about negative 27 is equivalent to 21x. Just going to simplify x, and it's going to be negative 27 over 21, which we will simplify as negative 4 over 3. And that is going to be our answer to this question. So now moving on, we're going to get to the second part of this lecture, which is try to identify how to use log. So so basically when you're looking at this, you want to know how to solve this, because you might be going like, well, we just have to just go like this and stuff. But that's actually not correct at all. That's completely incorrect. So I'm going to teach you the real way how to solve this. It's going to be using log 4 to the power of x is equal to log 23. So now that we can assume that this is equal, that we're actually going to take this x, move it to the front of the equation. So now we're going to rewrite the whole equation, saying that x log of 4 is equivalent to log of 23. So now we can actually solve for it, saying that x is equal to log 23 over log 4. So if you were to enter this into your calculator and try to find it out, it would be roughly, it should be roughly around 2.2618. That's going to be roughly your answer. So now we're going to move on and try to find using, since we talked about log itself, log base 10, then now we're going to be talking about natural log. So here's an example. 2, 2. So similar to how it was with our log functions, we're just going to instead equate that to natural log. So ln e to the power of x gives you ln 2. And now we're going to, like the last equation, we're going to move the x to the front. And so by doing that, we get x ln e is equivalent to ln 2. So now we just have to move them all to the same side. Ln 2 over ln e. And if you were to input that into your calculator, you should get about I get about roughly 0.69 0.693147. This is roughly my answer to this question.